To solve polynomial inequalities, first we move everything to one side as if we were solving an equation. In other words, make one of the sides 0, put everything all on one side. Then we find the zeros of our expression. What are the zeros of x squared plus 6x minus 16? Ultimately, I'm interested in where it's greater than 0. But first I'll find out where it's equal to 0. Sometimes I'll do that by factoring, sometimes quadratic formula, sometimes one of our more complicated things like rational root theorem. It looks like in this case, the zeros are -8 and 2. I take those numbers and I put them on a number line. -8 and 2 are on a number line. Now those are spots that I know definitely don't work in this inequality because they would make the left side 0, and 0 greater than 0, that's not true. So I'm going to put open circles there. And what these numbers do, -8 and 2, is they essentially break up the number line into 3 pieces. There's this piece, there's this piece, and there's this piece. I just need to choose one number from each piece to decide whether or not to include that region of the number line in my final answer. For instance, maybe between -8 and 2, I try x equals 0. Or past 2 is a number like 3. Or before -8 is a number like -10. I'm going to take each of those numbers and I'm going to plug it into the inequality. Either I'll plug it into this one, or I'll plug it into this one, or I could plug it into a factored version. I plug into one of those and see if it makes it true. If I plug in -10, let's just say I plug it into this, I get -2 times -12 is greater than 0. Is that true? Yeah, that's true. A negative times a negative will be a positive, so it will be greater than 0. So I will include this part of my number line in my answer. If I plug in 0 into, again, I'll do the factored version of it, I get 8 times -2 greater than 0. That's not true. A positive times a negative, no way it's going to be bigger than 0. I don't care what number it is. So I won't include this part of the number line. If I plug 3 in, I get 3 plus 8 is 11. 3 minus 2 is 1. 11 times 1 greater than 0, that's true. So in the end, the parts of the number line that I include are everything to the left of -8 and everything to the right of 2. My final answer would be -infinity to -8 union 2 to infinity. Solve polynomial inequalities. I put everything on one side, done. I find the zeros. I put those zeros on a number line. In this case, each of those is going to get a closed circle, because if I plug √5 or -√5 in, I know that that makes this 0. That's where those came from, and 0 will be less than or equal to 0. So those do work in our inequality. And then I test regions. A number to the left of -√5 would be -10. A number between -√5 and √5 is 0. 0 is always easy to plug in. And a number to the right of √5 would be 500. I don't know, just any number bigger than √5. If I plug in -√10, I'm just going to plug into this right here. I get 5 minus 100 is less than or equal to 0. That's gonna be true. 5 minus 100 will be less than 0. So I will include this part of the number line. If I plug in 0, I get 5 minus 0 squared is less than or equal to 0. That's not true. 5 is not less than or equal to 0. Kick out that part of the number line. And if I plug in 500, I get 5 minus 500 squared, which who really cares what that is? I plugged in a big enough number that I am positive that's going to come out to a negative less than or equal to 0, which is true. So my final answer goes from -infinity to -√5, including -√5, union with square root of 5 up until infinity. To solve polynomial inequalities, first I move everything to one side. Done, already all on one side. Then I find out what the actual zeros are. Quadratic formula time. X equals -b plus or minus the square root of b squared minus 4ac all over 2a Negative 4 plus or minus the square root of 16 minus 44 over 2. You know what? 16 minus 44, what is that? That's a negative number. What do we get when we do a square root of a negative? We get something imaginary. Something non-real. There's nowhere on our number line for that. This is the real number line. Get out of here, imaginary numbers. So, no problem. I don't end up putting anything on my number line. My number line is one giant region. It's not. There's nothing breaking up into multiple regions. It's just one region. So I could try literally any number I want. Plug it into here, see if it makes it true. 0 squared plus 4 times 0 plus 11 is less than or equal to 0. Nope, not true. So literally no solution to this. There is no x value that will make x squared plus 4x plus 11 less than 0. My answer would be empty set, or no solution. Or I'd draw a number line and not shade anything in kind of passive aggressively. Or I'd write a sad face. I don't think my math lab takes sad faces. But that's the right idea. Did I skip one? I think I skipped one. That's okay. X squared minus 10x plus 25 greater than 0. To solve polynomial inequalities, I move everything to one side. Done. I look for the zeros. My zeros in this case are 5 and 5. I put my zeros on our number line. In this case, it's an open circle at 5 because 5 would make this part 0, and 0 is not greater than 0. And now that breaks up my number line into two regions. I'll test a number from each region. And I'll plug it in. I could plug it into here, but just to make life easier, I'll plug it into the factored version. I think it's almost always easier to plug into the factored version if it factors, because then I can do this thing where I just pay attention to positives and negatives. If I plug 0 in, I get negative 5 squared greater than 0. Yeah, that's going to work. You take square a negative number, it'll be bigger than 0. So we will include this part. And if I plug 6 in, I get 1 squared greater than 0. Yeah, that's true. And in fact, kind of in retrospect, I realize, of course, everything's going to be true. This is asking something squared greater than 0. Something squared is going to be greater than 0 unless it is exactly 0. So all numbers are going to work except for that number that makes that left side 0, which matches what I got. I got that all numbers negative infinity to 5, and also all of the numbers from 5 to infinity work. To solve polynomial inequalities, I move everything to one side. Done. I factored. Now this is actually the same one that I had before. It's just a different inequality. Before it was a greater than symbol. Now it's a less than symbol. Well, or less than or equal to. The answer to this bottom one is going to be the exact opposite of the top one, because if that expression is not greater than 0, then it's less than or equal to it. So I kind of already know where it's going. But even still, I'll give it a try. I'll find the zeros. Put them on a number line. In this case, that point will get colored in, because if I plug in 5, I'll get 0 is less than or equal to 0. So that is true. 5 does make the inequality true. I test regions. If I plug in 0, I'll end up getting 25 is less than or equal to 0. That's not true. If I plug in 6, I end up getting 1 is less than or equal to 0. You can just trust me. I know that because I plugged it in up there. That's not true. So the only number that works here is 5. So my solution would be in set notation, I could just do this. Or to make it a little bit more formal in set notation, I could say the set of x such that x is equal to 5, but that feels like a lot of writing just to say the number 5. Or there's not really an interval notation way of doing it, because that's not an interval. But if someone said you have to do interval notation, I would either do this to say I'm starting and stopping at 5 and I'm including 5, or maybe I would do this to say, hey, it's just one number. But it's not really an interval. To solve polynomial inequalities, I move everything to one side. Done. I find the zeros. This was some soap I just did. Same sign. It was a minus, so I did same, opposite, always positive. And I know that the way that we factor a cubed minus b cubed is... I'll start off like this. Same, opposite, always plus. And then I put an a and a b here. I put an a squared and a b squared here. And in between, I multiply them. That's how I got this expression. So my zeros are x equals 1 and whatever makes this 0. But like so frequently happens with factoring sum of cubes or difference of cubes, this part is going to come out to be something imaginary. It's going to come out to -1 plus or minus the square root of -3/2 if I were to do a whole quadratic formula, which is complex. In other words, it has an imaginary part, which is interesting but not relevant to this problem because the things that go on in real number line are real numbers. The only real 0 of x cubed minus 1 is 1. It gets an open circle because it would make this 0. 0 is not less than 0, so 1 does not work. I plug in a number from the first region. I plug in a number from the second region, whatever numbers I want. If I plug in 0, I get -1 is less than 0. I'll plug it into here. Yeah, that's true. -1 is less than 0. Sweet. So I'll include this region. If I plug in 3, I get 3 cubed minus 1 is less than 0. 26 is less than 0? No, that's not true. So my solution to this one is going to be everything from -infinity to 1, not including 1. To solve polynomial inequalities, I move everything to one side. Done. I find the zeros. X cubed plus x squared minus 8x minus 8 equals 0. This looks like a good factor by grouping problem. I take an x squared out of the left side, take a -8 out of the right side. It turns into an x squared minus 8, x plus 1 type situation. This clearly has -1 as a 0. Maybe I factor this further by writing it as x minus root 8, x plus root 8, but that feels like a weird move. Maybe instead I just say, well, I wonder what makes x squared minus 8 0. Well, that happens when x squared is 8. That happens when x is root 8 or x is negative root 8. So we have 3 zeros. I'll put those 3 zeros on a number line. -1, root 8. Negative root 8 is even smaller than -1 because negative root 8 is like negative root 9 about. Negative root 9 would be -3. Negative root 8 would be -2 point something. This breaks up my number line into pieces. I tried a number from each piece. X equals -10 is going to be definitely in that leftmost piece. Between -1 and -8 it's going to be -2. Between -1 and -8 would be 0. Past root 8 would be 5. And you know what will make life easy? I'm going to plug it into the factored version. I'm going to plug it into x squared minus 8 times x plus 1 is greater than or equal to 0. If I plug in -10 in, the first parenthesis is going to be like 100 minus 8. It's a positive number. The second parenthesis is -10 plus 1. It's a negative number. Rather than actually figure out the number, I'm just paying attention to positives and negatives because that's all that I really care about. Positive times a negative is going to be a negative. Negative is not greater than or equal to 0. So we will not include this region. Oh, I forgot to actually shade in the points. Each of these will get a closed circle. Each of these gets a closed circle because they make this 0, and 0 will be greater than or equal to 0. Let's try plugging in -2. If I plug a -2 into this first parenthesis, I get 4 minus 8, which is a negative number. If I plug -2 into this one, I get a negative number. Is a negative times a negative greater than or equal to 0? Yeah, negative times a negative makes a positive. So this middle region will work. Let's try plugging in 0. If I plug a 0 into the first parenthesis, I get a negative. If I plug 0 into the second parenthesis, I get a positive. Is a negative times a positive greater than or equal to 0? Heck no, it's not. Get out of here. X equals 0. So I'll reject this whole region. X equals 5. This whole region had an election. They elected x equals 5 to be its representative. Let's see how it does. If I plug a 5 into the first parenthesis, I get 25 minus 8. Definitely positive. If I plug a 5 into the second one, 5 plus 1, we're only getting more positive. Is that greater than or equal to 0? Yeah, it is. So my final answer is I include the region that started at negative root 8, including negative root 8, and went to -1, including -1, and union that with square root of 8 to infinity. Hopefully this helps. Good luck.